Alright, combining functions. So we can have two or even more separate functions, and we can combine them with addition, subtraction, multiplication, or division. Now when we do this, because sometimes if you want to combine functions, especially with word problems, we have shorthand for it. So instead of with the addition listing it as separately the addition of the two fractions, we can use this notation showing the names of the functions adding together, and then they have this shared input. Same thing with subtraction, multiplication, division. And then for even more shorthand, since they're going to share the same input, we could just drop that of x part and just say f plus g or f minus g if we just want to see the functions combined. So let's look at some examples here. We're going to look at examples with some rational functions. With that, I'll also give a warning. We're going to do some fraction review here because we can always use a little review of fractions as well. Alright, so we have m of x and p of x. So we just want to make sure which letter relates to which function so that we keep those in order. So seeing this m plus p of 2, that's the same thing as taking m of 2 plus p of 2. I've written out in an expanded form. So what I'm going to do is plug in 2 to my m of x function. So where I have 3 over x minus 5, I'm going to plug in 2 for x. And I'm going to add that with taking p of x and plugging in 2. So where I have x minus 2, I'll have 2 minus 2 over 2 plus 3. This is where we can start to see our fractions come through. So on the left-hand side, I have 3 over, so 2 minus 5 is negative 3, plus 0 over 5. So this ends up being a negative 1 plus 0, so this is just negative 1. So we get a single value out from the combination of these two functions, and in this combination, we're having an input of positive 2. Alright, let's look at a similar case, but now we're taking our function p of x minus m of x, and we're having an input of negative 2. So this is the same thing as p of negative 2 minus m of negative 2. So with that, taking my p of x function, but for my x value, I'm going to plug in negative 2. So I'm going to have negative 2 minus 2 over negative 2 plus 3. And then subtraction with m of x, which is 3 over x minus 5, but I'm going to plug in negative 2 for x, so negative 2 minus 5. And then we're just going to simplify down. So we'll have a negative 4 over 1 minus 3 over negative 7. So this is going to be the same thing as a negative 4 plus 3/7. Now to add those fractions together, we can change our negative 4, or if we want to, we can use a calculator to help us out. But just for some good fraction review, just think about we want this denominator of 7 here, so I'd multiply that by a 7 over 7, which would be a negative 28 over 7 plus 3/7, which would give us a negative 25 over 7. So once we get that same denominator, in the numerator you just add those together, and then you keep your common denominator. If you need calculator support here, you can go to our Desmos Scientific Calculator. So negative 4 plus 3/7. And it will give you the decimal, but often with these, if we start in a fraction form, we want to end in fraction form. It just kind of depends on what we're asked for. But if you click the convert to fraction button, then you can see our negative 25/7. So if you need to check your work or just need some support with fractions, use the calculator. Alright, in this next one we're going to multiply the functions, and we'll have an input of 0. So we're taking m of 0 times p of 0. So m of 0, we'll have 3 over 0 minus 5, and we're going to multiply that with 0 minus 2 over 0 plus 3. So for the left-hand factor, we'll have 3 over negative 5, so we'll have this negative 3/5 and then times negative 2 over 3. If it helps, we can even attach the negative. You could keep it in the denominator, or that negative can move around as long as it only shows up once. I'm going to put it in the numerator. So multiplying fractions. We're going to multiply the numerator, so negative 3 times negative 2 is going to make a positive 6 over, and then you multiply the denominator, so 5 times 3, which is 15. And then we could just reduce that down. There's a common factor of 3 that we can take out. So we'll have a 2/5. We could have also done that in this step here by canceling out the 3's, and then you'd have your negative 2 or positive 2/5 there. That would work as well. All right. Dividing. So this is going to have m of negative 4 over p of negative 4. So m of negative 4 is 3 over, and then negative 4 minus 5. And then over, so we're dividing that with negative 4 minus 2 over negative 4 plus 3. So I'm getting a complex fraction here where I have fractions within fractions. So I'm just going to simplify that numerator completely. So that is 3 over negative 9. I'll just keep it in that form for now. Over, and then negative 6 over negative 1. Alright, so that numerator reduces down to a negative 1/3, and I'm going to write this in a horizontal way, so it's kind of vertically written right now. I'm going to write that as negative 1/3, and then that's being divided by, and negative 6 divided by negative 1 is just a positive 6. So when we have division with fractions, I always use the phrase keep, change, flip. Meaning, we keep the first piece so that negative 1/3 stays the same. Change the symbol, so where we have division, we're going to change that to multiplication, and then flip your number. So where this is 6 over 1, we're going to flip the numerator and denominator. So it's that division with fractions turns into multiplication with the reciprocal. That's the real terminology. I just like keep, change, flip. That's kind of the quick way of remembering. So this will be a negative 1 over 18. And we're done. So with these complex fractions, once you have your numerator and your denominator, write it in this horizontal way, and then use that keep, change, flip. All right, average rate of change. This is going to be a big one. So we're going to look at the average rate of change of this combined function from x equals 1, negative 1 to x equals 2. So what we're going to do is look at the subtraction of the functions. And then remember our average rate of change. So what that would look like with just a standard function would be f of 2 minus f of negative 1 over 2 minus negative 1 is what we would be using. But what's going to change here is where instead of f of 2, it's going to be this m minus p of 2. So what this will look like is m minus p of 2 minus m minus p of negative 1. So there we have the difference of our function outputs all over 2 minus negative 1. So let's focus on simplifying, or rather just plugging in this first piece, m minus p of 2. So I want to look at the subtraction of my two functions with 2 plugged in. So m of x, I would have my 3 over x minus 5, but I'm plugging in 2, so I'll have a 2 minus 5. And then minus p of 2, so my function p, where I'll have 2 minus 2 over 2 plus 3. So that right there matches up with what I highlighted in red up above. Now what I want to do is do the same thing, but plugging in -1. And then I'm going to have subtraction between these two pieces. So I'm going to have my subtraction symbol, and I'll start parentheses, and I'm going to do the same thing, but plugging in -1. So 3 over -1 minus 5 minus -1 minus 2 over -1 plus 3. And so that all matches up with what I highlighted in yellow up above. And then all of this is over 2 plus 1, so 3. And now we just start simplifying. So in those first parentheses, I have a 3 over -3 minus 0 over 5. I'll simplify those further. 3 over -6 minus a -3 over 2, all over 3. So in that first set of parentheses, I have a -1, and then minus 0, so that'll just be a -1, minus a -1/2 plus 3/2, all over 3. And we're going to keep going. So -1 minus 3/2 minus a 1/2 is going to be 2 over 2, so that's just 1, all over 3. So this simplified pretty nicely to a -2 over 3. Again, some fraction addition in there. Luckily we had all same denominators, but that's what it comes down to. So it's just plug in carefully. Take your time plugging in with these, because that's where going too quickly can make these little tiny mistakes. And then once you plug in, it's just a matter of simplifying it down.